sometimes like one of
Okay.
the things I find sometimes hardest to remember all these formulas, and because sometimes they don't intuitively make sense to me, but sometimes
Mm-hmm.
making a quick drawing, does help like that. And so similarly,
Mm-hmm.
we can do the same thing. We can actually take that 3 and bend it up.
Mm-hmm.
Okay, and we still have 3 squared plus 4 squared. But now, whatever this third side is,
It will be less than. It will be, yeah, less than
yeah, so in this case, a squared plus b squared, we'll call those a and b.
is
It's
greater than c squared.
and that's acute. So you have to know these definitions. How do you want to remember them? It's totally up to you. I
Mm-hmm.
would probably just um, I actually like defining them on the fly, but
Mm-hmm.
that's it there. So let me go find a couple of practice problems that are a little bit more difficult than these. That's not what I want. All right, so here is a problem for us to do. Actually, let me take this back here. So let me make this a little bit more difficult for you. Let's say I just give you the 3 sides. I tell you that's 9, 12, and 17. Okay. I won't draw it. I won't even attempt to like force it on you. I want to know if this is acute, obtuse, or right.
It will be, first I have to find the square root of each of them. So I'll do 81 plus 144, and that will give that, and then 17 give that. It would be an obtuse triangle.
Okay. And how confident are you in that?
I'm very confident.
Okay. So you found that a squared plus b squared, 9 squared plus 12 squared. So
Is less
basically,
than 17 squared. Yes.
yes. So we got 289. This is 144, 81,
Mm-hmm.
and it is less than that. So by definition, it is obtuse.
Mm-hmm.
Now, did you actually talk about whether the triangle lengths whether they can actually make a triangle?
We did.
Okay, because that's also important here. Like I could give you a problem like this, like 1, 16, and 19,
Mm-hmm.
and you
It'd
could
be
sit here
impossible
and you could,
because it's too short.
right. And so you don't want to just go and like first thing you have to decide, like, is it a triangle?
Mm-hmm. Yeah.
And then you can decide whether it's acute, obtuse,
Yeah.
or right.
Mm-hmm.
All right, so
Mm-hmm.
here's another problem for you to look at here. Not drawn to scale, so don't make an assumption just because the way it's looked,
Mm-hmm.
because the way it looks here. Again, just tell me whether it's an acute, obtuse, or right triangle, please.
All right. So do 15 squared. Squared times 2. It is an acute.
Okay, so we have 2 square root of 14
Mm-hmm.
squared. Did you get well, tell me, why don't you tell me what you got here for that one?
So I I found the square root of 14, which is, sorry, it's a long number. Here, let me
Okay,
pull it
so
up.
that's okay, because that sounds like maybe going the wrong direction. When you square root, it undoes the square root.
So just be 14 times 2.
Times 4 times 4.
Oh yeah, times 4.
Yes.
14 times 4, and that would be 56. And I do 56 plus 144, which gave me 200. And I do 15 times 15, which gave me 225.
Okay, so what's your answer here? Sorry, maybe I
Uh,
missed that.
obtuse.
It is obtuse again. Good. Okay. Think you've got that down. Now, are you actually solving right triangles?
Yeah.
Like solving for missing sides and things like that?
Yes, we are.
Okay. Um, let me grab a few problems here. me see if I can find something a little bit more difficult for us today.
I think I got it down pretty well. I think I understood this one.
Yeah, I just, so I'm looking for, these are harder versions of these. They're with variable expressions,
Oh,
because these are harder for me to make up on the fly. So I gotta, what else are you guys working on in class?
that is all we've worked on so far.
And do you have any idea what the next unit or
Nope,
next class will be? Does your
no
teacher
idea.
doesn't post to Google Classroom or anything
Mm-mm.
like that?
Nope. She just hands us the packet the day of.
Okay. All right. All right, so let's do some story problems here that'll where you've got to actually make a drawing here.
Mm-hmm.
All right, so here we go. Rectangle has a diagonal 2 and a length of square root of 3. Find its width. Okay, so this
Mm-hmm.
is all about you trying to make a drawing, of a rectangle here,
Mm-hmm.
labeling the appropriate sides and solving for the missing.
Mm-hmm. So a diagonal of 2. So that would be the area of it, right? I want the
Yeah,
area to be 2 then, right?
nope, you don't. The area is not part of this at all. Nothing for area.
Oh, hold on. Diagonal is 2. Height is, oh wait, no, this is just a triangle, but oh, okay. I got this. So the length is 3 squared, so I want to do find, so 3 squared would just be 3, and I need to figure out what that would be. 2. The width would be 2.
Okay, so your drawing should look something like this. I don't know whether you went diagonal down this way. Did you go this way or did you go the other way with your diagonal?
That way.
That way. Okay.
Mm-hmm.
So diagonal 2, length is square root of 3. So your
Mm-hmm.
missing side is b. Square root of 3 squared plus b squared equals 2 squared. Okay, so
Mm-hmm.
b would equal 1. I think I might have heard
Oh,
something a little
1.
bit different there.
Okay. Yeah,
Okay,
it would be 1.
now that we've got that, let's find the area of the rectangle.
It would be 3.
So the area is base times height. What is the base?
Oh, 3 squared. It would be. It would just be 3 squared.
So the base is square root of 3, but what is the height?
1
1. What is the square root of 3 times 1?
square root of 3.
Yes. How about the perimeter of the rectangle?
It would be square root of 2 square root of 3 plus 2.
Very good. Okay, let's try another one of these.
Mm-hmm.
The challenge really is like drawing it correctly.
Mm-hmm.
If you ever want me to check your drawing, before you proceed, I'm happy to do that. But um, take a look at this one, see what you
Mm-hmm.
come up with, please.
Mm-hmm. So each side would be 4. Find the length of a diagonal. Mm-hmm. Let's find. All right, then. So it would be 16 plus 16. That'll give me 32. Sorry. Anyway, square root of 32.
Oh, sounds good. Keep going.
Yeah. It would be A 5.65.
Okay, so no, we don't want to use the calculator in this. Like this is correct, but you need
Okay.
to be able to reduce the root.
Oh, okay.
And you're
So I need to
looking,
break it down.
yeah, you want to build a factor tree or
So
factor ladder.
it would be, so first I do 32 divided in half by 2, which would give me 16. I do 4 by 4, and I do 2, 2, and so that would be 4 on the outside, 2 on the inside.
Yes,
4
now
square root of 2.
just a small, just a small little modification, what you said. While you can do it the way you said, and it happened to work in this problem, it's better to keep
Mm-hmm.
trying the number until it doesn't work anymore and then circling pairs. That way you avoid
Okay.
missing
Okay.
certain ones. But your answer is correct, so it's hard for me to be too difficult or harsh on you because you got the right answer, which really does matter.
Uh-huh.
All right, let's do one more of these, and then we'll move to trigonometric ratios.
Okay.
All right, so again,
Yeah.
that's a triangle problem. You're gonna draw a triangle and solve for the missing side.
Make it better. Right. I need to find. So I do 20, 100, and I do 2, 2, 5, 175. It'll be square root of 175, and then I need to break that down, right?
Let me just double check here. Help me out here. Does your drawing look like this or the one on the right? Both are correct.
One on the right.
Okay. So let me just label these real quick. A, B, and C. Which of the two? You have two of the three.
C is 20.
Okay.
B is 15.
Okay, very good. And yes, you're right. You do have to reduce the square root of 175. You're going to try prime numbers 2, 3, 5. You want to go in that order though.
Okay. All right. So I'll do 1. Okay. So 5, it'll be 35, and 5. And then I do 7 and 5, and it'll be 5 square root 7.
5 square root 7. Now this one has units, so you'd want to put feet there.
Feet. Yeah.
But that's very good. Okay.
Mhm.
All right. So I think you've got that down pretty well here, at least as far as I can tell. Now we're going to talk about maybe something new here. So trigonometric ratios. Have you heard of trigonometric ratios before?
Nope.
No idea what I'm talking about.
Absolutely nothing.
Okay. Well, this is generally the direction you're going, but I don't know. Just a guess here. So in a triangle, given triangle like this, there are 3 sides and 3 angles.
Okay.
Okay, I'm just going to label it A, B, and C. You know, A, little B, little c here, like that.
Okay. All right.
So there are 6 trigonometric ratios. We're just going to focus on one of them for right now. The sine of A, and this is our first trigonometric ratio. It's sine. It's pronounced sine, not anything else. S. This equals the opposite over the hypotenuse. Okay.
Okay.
The opposite side over the hypotenuse.
Okay.
So the idea is, let's say you were standing here at A. Opposite is A. The hypotenuse is always the longest side. Okay.
Okay.
The next one we're going to look at here is cosine. So the cosine of A ends up being the adjacent side over the hypotenuse. And you've never seen this before.
Nope.
Okay. So if you're standing there at A, The adjacent side is B. Now you might wonder, well, why isn't C the adjacent side? The word adjacent means next to, and you're kind of right. C is adjacent, but C is actually the hypotenuse. The longest side in the triangle is always the hypotenuse.
Okay.
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 And then the last one here is tangent of A. There's actually three that generally start out here. And this is the opposite side over the adjacent side.
Okay.
Okay, so these are very difficult to remember in some cases. So they make some mnemonics for this. So the one that you need to know here is, and sometimes it's written like this, so, ka, toa. I don't like that as much as I like writing it this way, SOH. So what this means is S is for sine, the O is the opposite, H is the hypotenuse. Ka, so CAH, C is for what's called cosine, A stands for adjacent, H is hypotenuse. T stands for tangent, O stands for opposite, A stands for adjacent.
Okay.
Okay, so we're going to do one problem here together. We'll see how well this goes. Don't worry if you don't get it down. Since you haven't seen it yet, I don't want to overemphasize this. Let's go back to this 3, 4, 5 triangle. Okay. The sine of A is the opposite over the adjacent. I'm sorry.
Okay.
I'm sorry. Over hypotenuse. Oh, I misspoke there. Relative to A, which of the three sides is the opposite?
4.
4. And the hypotenuse is
5.
5. So the sine of A equals 4/5. Cosine of A is the adjacent over the hypotenuse.
So it'll be 3/5.
Be 3/5. The tangent of A is the opposite over the adjacent, which would
It'd
be
be 4/3.
4/3. Okay, so you're like, oh, I got it. Let's look at another triangle here. Let's say it's 6, 8, 10, and this time we're going to go up here and let's say A is there.
Okay.
The sine of A, you go imagine you're there at A, you're looking for the opposite.
It'd be 6
over
10.
Now, does this fraction reduce?
Yes, 3 to 5.
3 to 5. So you always reduce the fraction. How about the cosine of A? What is that? Adjacent.
That would be 8/10, which would reduce to 4/5.
Good.
And then it'd be 6/8, which can reduce to 3/4.
Very good. Okay, so that the key here is this so ka toa. You can remember this. You won't have any problems here. So let's do a triangle here from start to finish.
Okay.
So here's how the problems generally are set up.
Okay.
I'll tell you that this is 8 and this is 17, and I want the sine of A.
Okay.
That means you really need the opposite side over here. Do you have the opposite side?
Nope.
So how do you find the opposite side?
17 times 17 minus 64, 225 squared, which would be 15. So I know it's 15, and that would be 15/17.
Very good. What is the cosine of A?
Cosine would be 8/17.
And how about the tangent of A?
15/8.
Very good. Okay. Now watch this. Let's put B up there. What is the sine of B?
Sorry. It would be 8/17.
Does that look already over here on your list?
Yeah, it would be the cosine of A.
That's interesting. We'll get to that here at some point. What's the cosine of B?
It would be 15/17, which is a sine of A.
How about the tangent of B?
It would be 8/7.
Now, is that good?
Wait, no, hold on, no, 8 over 15, sorry.
Now, is that there on the right?
Nope.
It's but kind of isn't, right? It's flipped, right? But it's not the same.
Yeah. Uh-huh.
Okay, so there is this relationship here between sine and cosine
Mhm.
that you might see here. All right,
Uh-huh.
so yeah, it's hard for us to really get anything else today. So sine cosine tangent is always paired. It's always paired with the Pythagorean theorem, PAG, if you
Okay.
will. A squared plus b squared equals c squared. There's way more here, but this kind of just touches the surface of it. It's just, it's only so much we can get into in these short lessons here. So I'm going to
Okay.
go ahead and stop here for today.